Okay, in this question I'm starting with binomial distributions and I'm using the Poisson approximation to that where it's appropriate. There might be one case where it's not. So, first case, I've got an n of 100 and I've got a p of 0.05. So n is large and p is small. And at the top of this page we've got the crib sheets, okay? Alright, you don't get this in the formula book, but we know we need a large n and a small p. I've got a large n, I've got a small p, so it's appropriate, okay? Then I need to set up the correct Poisson, okay? So I know for a binomial with parameters n and p, I can work out the mean using np. That is on page 13 of the formula book. And of course for a Poisson, I need a lambda, which is the mean. So this describes all I need to do. I need to set up a Poisson with the correct mean. So my lambda, which is the mean, is going to be np, which is going to be 100 times 0.05. Okay, actually let's do this properly in the space down here. So for part A, okay, lambda equals np equals 100 times 0.05, which is 5. Okay, so I'm going to be using the distribution of Poisson with mean 5. Okay, and then all I need to do is my separate probabilities. So I want the probability of x being less than or equal to 4. So I do my list of outcomes. So 0, I'll have 4 and 1 on either side, and then dot, dot, dot. Now for the original binomial, it would go up to 100. For a Poisson, it goes on forever, but it makes no practical difference because there hardly anything at that end of the distribution happens. Okay, and certainly where we are, I've got all the outcomes that I care about. I want x being less than or equal to 4, so my box just goes like this because these are ticked, these are crossed, so I just need a single probability. So I go onto my calculator, I go onto Poisson CD, let's start again, because I think I'm just going to do the variable approach. So we have got an x value. Well, I've got values of 4 and less, so I need to put in x is 4, and my mean is 5. That was already correct. So my probability is 0.44049. So p equals 0.4405 to 4 significant figures. So that's the first part done. Right, dot 2. Same distribution, but now I want the probability that x equals 4. So list of outcomes, dot, 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 3, 4, 5, dot, dot, dot. Now I want 4, I don't want 5, I don't want 3, I don't want anything else. So my big box includes the 4 that I want, and then I need to get rid of the outcomes I don't want. So therefore I need to do the probability of x being less than or equal to 4, and take away the probability of x being less than or equal to 3. So I've got the first one, the probability of x being less than or equal to 4, I already know is 0.440, it was actually 49, a bit more accuracy for this. And now we need to, on our calculator, we can just go back and look at x is 3, and get the probability for that, same mean. So 0.26503 minus 0.26503. Take away these two probabilities, and to 4 significant figures I get 0.1755. Okay, and then finally for the last one, I want things between 2 and 6, but not including 2 and 6. So for part 3, okay, list of outcomes, 2 is going to be less than x, is going to be less than 6. So my list of outcomes is 0, 1, 2, 3, dot, dot, 5, 6, 7, dot, dot, dot. So I don't want 0 or 1. I don't want 2. So it's got to be bigger than 2. Okay. I do want 3. I do want 5. I don't want 6 or 7 or anything higher. Okay, because it's got to be less than 6. So therefore my box that includes everything I want comes up to 5. My box that gets rid of what I don't want comes up to 3. So I need to do the probability of x being less than or equal to 5 minus the probability of x being less than or equal to 3. I get those two probabilities from my calculator. I'll find it. Here we go. So the probability of being less than or equal to 3, that's already done. That was the same one that I had here, so I can use that one. But the probability of x being less than or equal to 5 is 0.61596. So that's the probability of being less than or equal to 5. That's the probability of being less than or equal to 3. I subtract those and I get 0.3509 to 4 significant figures. So we've done that one. So we've done all of part A. Okay, on to part B. So in part B, I've got an n of 60 and I've got a p of 0.3. Now the conditions are n must be large. Yes, 60 is large. P has got to be small. Now 0.3 is not close enough to 0. So therefore for B, we're just going to say not appropriate, and we're going to say why. So not appropriate. Okay, question says explain why it's not appropriate. If not, because P equals 0.3 is not small. Okay, so on to part C. So part C is going to be very like what we did before. We've got an n of 75 and a p of 0.07. This is large, this is small, so we can go ahead and do the approximation. So what do? We've got an n and a p. We need a mean for our Poisson distribution. So we need to work out our lambda. So lambda is n times p. So n for this one was 75 and p was 0.07. So we need to do 75 times 0.07. Okay, calculator. Here we go. 75 times 0.07 and 21 over 4 is 5.25. So we have got an answer of 5.25 for our lambda. And we've got to do a Poisson, therefore, with mean lambda, which is 5.25. And the probabilities we've got to do are being less than or equal to 5. Okay, so in dotty 1, x less than or equal to 5. List of outcomes, 0, 4, 5, 6, ... I'm interested in 0 up to 5, but nothing beyond 5. So my box comes like this. So I just look up the probability of x being less than or equal to 5. So x value of 5, our mean of 5.25. Probability is 0.5722. That's the first part finished. Next part, x has got to equal 5. X is 5. List of outcomes. I don't want 0 or 4 or 6. In fact, I only want 5. So the box that includes that is this one. And the box that gets rid of what I don't want is that one. So I need to do the probability of x less than or equal to 5 minus the probability of x less than or equal to 4. Okay, I've already got the probability of x being less than or equal to 5. It's this value that I've still got on my calculator. Let's use an extra significant figure this time, so 0.57218. And let's work out the probability of being less than or equal to 4. And that's minus 0.39777, giving an answer of 0.17441. I make that. Okay, so that's my answer to dotty 2. Last part, between 3 and 7, not including either. So I don't want 0, I don't want 1 or 2. I don't want 3 because it's got to be strictly greater than 3. I do want 4. I do want 6. Do I want 7? No, it's got to be less than 7. So I don't want 8 either. Box that includes everything goes up to and including 6. Box that gets rid of what I don't want goes up to and including 3. So I need to do the probability of x being less than or equal to 6 minus the probability of x being less than or equal to 3. 0.72479 minus 0.23167. Subtract them. 0.49312. I make that. Okay. So that's that question done.